Thank you, Nadia. Yes, that's true. You have to get used to the light. I will first introduce myself. I'm working at the Fraunhofer Institute since a long time ago, and I'm coordinating this activity, Green ICT at FMD, this specific SEC Sensor Edge Cloud Hub. And so a lecture, I will give you some examples, why we are doing this, we can start maybe with the first agenda, why we are doing this activity, what is the motivation behind, what are the potential of savings. First of all, everything in, can you hear me? Maybe I'm not loud enough? A bit louder. Okay. Thank you. So I will give you first an overview about what we are talking about, Sensor Edge Cloud. What is this for? What is the basic, the principal infrastructure, principal modules? Why and how can we make them green, or more green than they are maybe today? And later on, after the first introduction, I will take on to my colleagues, Peter and Maximilian and another Peter. They will come and give you some more details about some reference technologies, as we call them. And just at the end, to give you some, an overview about the. Okay. Yeah. We hear so I hear the difference. You hear also the difference? Yes. We'll give some 2 slides about the SEC Camp team. They are not only persons from the FMD, from Fraunhofer IIS, when you hear, but also from Fraunhofer IZM, that there are more specialists in the topic how evaluating sustainability. So let's start. Are you ready? So the introduction of the Sensor Edge Cloud chain. Sensor Edge Cloud, that's somehow similar to IoT, building an IoT network. Means you get at the sensor stage information, anyhow, can be environmental information like temperature, humidity, but it could be also something like current, so how many energy is here at a certain place, and so on. Then you have the information, you have different possibility, you transmit directly all the information you have measured, the mass data, the measured data, through the chain, or you started some processing already in the sensor platform, but you can also use AI in the sensor platform. That's one place. So you need then, depending how many data you have to transmit, you need a certain kind of IoT radio network. And they are very different from the energy consumption, depending if you have large band to transmit, a lot of data, megabyte, or just kilobytes sometimes. The next step is edge computing. Edge computing can be an access point, can be a gateway, can be a base station, depending on the radio communication you have. Then at least all the gateways are linked to a central station, can be a server, can be a cloud. So this is the basic infrastructure.
Are we allowed to ask questions now or later?
Oh yes, of course. We have time.
I have a question. Is the AI running on the sensor platform or on the cloud?
Can be
Both.
Can be both. So Usually, there are some use cases where AI can runs in the sensor platform. There are use cases where they're better to be run to the cloud. And that is also why we are doing this, because we are benchmarking both. What is for which use case? Because it depends on your use case, in which application you use it. So if you have a use case where it makes sense to do this, for example, do you have an example?
You do it on the sensor platform, for example, when you don't have the connection to the edge cloud. So
yes.
The connection to transfer the data to the edge cloud, but when you don't have the connection, you have to do it on the sensor itself.
That's a good answer. That is one.
And also for confidential things.
For
confidential things.
Yes, that's also good. So when you don't have to transmit all the data through the old chain and get a control to know what to do, that I have to go back to the switch chain. What is the problem? Just a finish. The latency, great. Privacy.
Yeah.
Exactly.
Do you also benchmark split learning or split AI? So the first part is on the sensor platform and the second part is then on the cloud. Like for security reasons and private reasons.
Very good question. I will say Maximilian will answer this question later on. Okay. I will move to this. So depending on the use case, always what in order to validate the benchmark, what make more sense. So there is not one answer. Yes, it makes more sense this, or it makes more sense there. It's depending about the scenario. That's right. So I was on the edge compute. Yeah, edge. So this is the basic infrastructure, and this kind of infrastructure, IoT, you have this quite everywhere today. To the digitalization of the society, you have smart homes, also buildings for the industry. You have such kind of installation for smart cities, for the controlling the traffic, for example, controlling also in smart metering, so controlling current, water, whatever, the energy grid, smart. So IoT are everywhere quite today. Also in agriculture to keep the plants and the side, wet but not too wet. Exactly the water they need. Construction, production, and so on. So the main role of this kind of system is the optimization of process and helping for very quick decision making where it needs to be. So our goal in this case, because it's the use is exploding, is to see where we can save energy, getting the same performances. We have to save resources, material, all kind of metal. We have a lot, but they cost. Yeah, they cost, save cost. But also not only material device, but also water and gas, maybe not healthy gas, and so on, for the semiconductor technology. Okay, so it's a pretty old slide. It's over 10 years old, but the meaning of this slide is still the same. So we don't have today 50, we already have over 50 terawatt hour today. But you see that there was, through the pandemic, a smaller a hole in the use, the annual energy consumption in Germany. But it's increasing and is increasing really faster at where it was planned today. And just to see here, the trend is rising extremely because of AI application quite everywhere in smartphone, in every kind of application you have AI behind. Everybody, even child, is using GPT and so on. So this is one of the explanation, but the extension or the explosion of the growth of ICT everywhere. You have 5G, we'll come to 6G, but in 5G just also this kind of mobile telecommunication system exploded in terms of, in the base station of energy consumption. So we see 55 terawatt in 2030. There are now the number of quite 70, yes, 70 terawatt hour.
Do you know the reason why the household percentage dropped in half? Or like, well, not the percentage, but the households, like the 28 and 2010
Drop here.
to 13?
What was? ICT in household was a yes. That's not. I don't know. Peter will be here. It's not here, but maybe I will ask him. We can ask.
Efficiency of the devices, right?
Mm.
A lot of movements, but now you see also that might increase again.
Increase.
The number of devices now.
The number and maybe more intelligence also in the device.
So screens are also part of the ICT?
Yeah.
Ah, okay.
Yes. So maybe just taking attention, you will hear a lot of this the next days. We are calculating. We can transfer the terawatts, so the energy consumption, into a carbon footprint. But of course, this is depending of where you're consuming this. If you're consuming in Germany, or in France, or in Asia somewhere. We speak about an energy mix, which is in Germany about, today, 400 grams CO2 equivalent per kilowatt hour. That is higher in most of the places where ICT is produced. Just to explain. So now, where are the potential? So I have to take care because I can speak a lot. What is the levers for savings? Context smart, making them smart. Can be. Context integration, making state-dependent control, control mechanism. A dynamic selection of the information you want to, that will go through the chain. What is relevant? Do we need to keep every measurement? Do we need to save them in memories? Do we need? Can we extract other source, the information, and not set any raw data? Such kind of ideas behind. The control of the hardware platform. A very easy law. Switch off, no energy. And that's the base of this, the base idea behind putting some sleep mode. I don't know if you know about, in 6G, they are talking about network efficiency, and they're introducing sleeping mode. So you have deep sleep, light sleep, and so on. I think it's domination very funny. Of course, the use of resource-efficient components. Since, for example, with some idea about good power management in your chip, you can also reduce the energy consumption of one element. Saving effect and impacts, less data to transmit, less data to temporarily save. the optimization of the resource utilization, for example, processors of memory. And also at the end in the cloud, you can reduce, if you reduce the service, so you don't need at the cloud to make so much to have so much task to do, or if you have a more efficient server that makes the same task but with lower energy, then it doesn't need to be so cooled. It will not produce so much thermic energy. That's also a cooling effort is very, very energy consuming. So to get maybe more deeper now in technologies, we will see, and you will work also in different workshops. There is one workshop will be focused on embedded AI, one workshop about self-powered IoT nodes that are more placed on the sensor platform itself. Of course, energy efficient radio communication is also part of the self-powered IoT nodes, because the nodes need also to transmit over radio communication. So you have a transmit or a transceiver behind, and it depends about the standard you have after. So you use. And at least there is also the workshop about the distributed embedded system, when you learn certain method how to calculate the carbon footprint over the chains. It implies edge computing, and a distributed platform can be on the server, on the edge, or both. We have also an extra, we check an extra point in the project. It's not integrated here in the workshop. To make the servers, you need a DC-DC converter at the beginning we take over a hardware. It's a hardware design topic. The point of load, taking a new design and increasing or allowing a reduction of consumption of the server platform itself. So we took care about the possibility also how to make a server platform more efficient. We have also in the technology in the hub a multi-sensor platform. They are measuring IMUs, so inertial measurement units, and taking care about or benchmarking the different sensor platform for the energy consumption, but also from the hardware itself, because the hardware is material, is all the processing, the production, and so on. You will learn this about the whole life cycle, and that means also carbon footprint. So I think 10 o'clock. I will, on the next time now, we will go through the relevant green ICT technology as I introduced before. And I will ask my colleague Maximilian, our Edge AI expert, embedded AI expert, to take now the floor. The floor is yours. Thank you.
Thank you.